Modest channel. Okay. What are we going to talk about today? Well, we're going to talk about a couple things. First, I'm going to do a little recap on time, which is what I did last week. And there were a couple loose ends, so I want to tie them up. And then there's our resident bozo clown, a guy who came over and criticized the theories and our understanding of the mainstream theories. I'm going to address that. And then at the end, I'm going to have the main course, which is black holes. And I'm really not going to talk so much about black holes, but the fact that, you have all these headlines out there and they promote the black hole. And the question is whether these headlines, this yellow magazines, whether they have anything to do with science, with physics. Okay, so let's get started here. Let me talk about. Let me start where I ended off last week, which was a summary of time. Okay, and it includes the definition that we propose here in this site. Okay, so let's start with that. I said physics has no use for time. Time describes, physics explains, and a lot of people have trouble with that. They say, "Hold it, we've been doing time since the days of Aristotle, at least, if not Plato or even before." Yeah, but the issue here is that time has nothing to do with physics. Time is a mathematical concept. Okay, it's you use numbers to depict time, and so and it describes. So it has nothing to do with physics. Physics is about explanations only. Only about explanation, qualitative explanations, physical interpretations, mechanisms, causes. That's what physics is about. Physics is not about describing, a chair and how big it is and that you measured it and you falsified it and verified it and all that other nonsense that mathematical physics proposes. Physics is not about measurement or equations. In other words, descriptions, right? The role of physics is to provide physical interpretations for how, meaning why, right? The universe works, causes and mechanism. Whereas motion is out there, time is in here. Time is in your brain only. Time is in the brain of people. It's not out there. There is no time out there. All we have out there is motion, Earth going around the sun, atoms, etc. All they have is motion. They recognize no time. Time is what we humans, living entities, could be lions, etc., recognize time. Why? Because we have memory. That's why. And there you see, time requires memory. Time requires an observer. Time requires a recording device. You have to record the previous location, and that takes us to our definition. Without a living entity memory, right, objects simply move in the universe. That's all we have, motion out there. There is no time out there. Time requires someone to make a comparison, and there you have our definition. Time is a comparison between two motions. That's what time is. In order to do that, you need to record the location of both objects that are moving, and then make a comparison. So you need to record, you need to memorize the previous location. And there you have an example. The second hand on your watch moves one tick mark while the Earth travels 30 kilometers around the sun. Okay, so that's what we're doing. We're comparing two motions. Okay, so that's essentially how we ended last week. And our resident bozo, or clown, he had something to say about that. So let's see what he has to say. He says the following. He says, time didn't start with observers. Time in physics isn't observer dependent. And he says bgaede's dismissal ignores that time is inferred from physical processes, not human perception. What does he do next? Well, he talks about observers. He says, evidence supports time existence pre-life. These are based on what? Observable data. Mainstream mathematics, right? What he calls physics, explains time via math and what? Observation. And then he says observers in different reference frames disagree on simultaneity. Yeah, observers. Without observers, you have no special relativity. You need observers. You need people who measure. Black hole event horizons, where time freezes from what? An external view. What is that? An observer. So he says it has nothing to do with observers, and then it turns out all his examples, all of what he talks about is observers and observation. Then he says something startling. He says the arrow of time shows time's directionality. No, time doesn't have direction. Direction is a qualitative concept. It's got nothing to do with quantities, and time is about quantities, other than, when you talk about before and after. But before and after has no directionality at all. So, no, time does not have direction, and that's where the mathematicians always say that it does, but it doesn't, because what they are trying to do, they're getting their number lines, which represent time, to have an arrow at the end of the line and say, oh, see, there's the direction of time. It increases in that direction. No, time does not have direction, okay? And if you feel otherwise, just point to time in which direction the future or the past point to, okay? So I need for you to point with your finger in the direction of the future or the past. Anyways, practical time, he says, travel is unproven. Practical time travel is unproven? It's not peddled as fact. It's speculative in physics. Well, here again, this poor fellow, this clown, maybe he's just joking around, but he doesn't understand his own theory or his own religion, right? Because, yes, in special relativity, in general relativity, time travel to the past and time travel to the future is more than just a theory. It's a fact in those religions, okay? So let's get that right. And again, all these people make fools of themselves because they come here and they don't even know their own religion. And so let's take a trip at warp speed, with the Enterprise. Let's see where it takes us. Here goes, okay? Be ready for a trip. Go. Here we go. Get ready. Zoom. Okay, so we're gone, right? Where did we go? Well, let's say we went to the past. Okay, so we're going to see the dinosaurs, maybe of the Jurassic or the Cretaceous. Okay, so here goes. Okay, watch. We're going to see our dinosaurs. Long next year, Jurassic. Is this possible? Is this just wishful thinking, or is this real? I like how they tear the guy up. That's great. Great movie. But a lot of people believe in this. They think that we can actually go to the past. Maybe not to the dinosaurs, maybe, I don't know, Permian, or even closer by the Neanderthals, Neolithic, whatever. Okay? Is that possible? Can we travel back in time? Kill our grandfather, that kind of thing? Well, let's see what the powers that be, the great gurus of math, have to say about it, okay? Here's one fellow, I guess you know him, his name is Brian Greene. This is what he's got to say about time, the arrow of time, right? Direction.
Time itself seems to move in only one direction, toward the future. We call this the arrow of time.
Now, is that ridiculous or what? I mean, he's talking about the arrow of time. He's suggesting it's got direction, and the direction is towards the future. Is the future a direction? I mean, please tell me. Well, the AI, I consulted with them, see what they have to say about, whether we can go to the future or not. And this is what the AI had to say. It says, special relativity predicts, they always predict, right, that traveling late into the future is possible through time dilation. Okay, that's what special relativity says. You can go to the future, right? So far, so good. Maybe not to the past, but yes to the future. A phenomenon where time passes slower for an object moving at high speeds relative to a stationary observer. By traveling at speeds approaching the speed of light, a person would experience a shorter duration of time while much more time passes for everyone else on Earth. So this fellow travels, at the speed of light or faster than the speed of light or whatever, and somehow time goes slower for him and faster for the people on Earth. So people are becoming older and older, I guess, on Earth, while this fellow is staying the same or getting or increasing his age at a slower rate, right? That's what they're saying. This means a traveler could essentially jump into the future. He can go into the future, right? He's going to jump into the future, right? Experiencing a brief personal journey while centuries pass for the rest of the world. Does this make any sense? We're saying here, this guy goes to the future, right? Somehow, he travels on his ship faster than the speed of light, or at the speed of light, we don't care. And they're saying that for him, time passes much slower than for us. Therefore, if he were to return, if he were to come back, he would find us all old while he's still young. That's what they're saying, okay? And you say, well, that's just a theory, hypothesis. No, it's been proven. It's a fact now. Here it is, okay, from the same AI, okay? Experimental evidence, okay? Now we're not talking about, speculation. We're talking about experimental evidence according to the mathematicians, right? We have atomic clocks. Time dilation effects have been experimentally proven using atomic clocks. What part did you not understand? Okay? When one clock is flown on a fast-moving airplane or placed in a different gravitational potential, it ticks slower than a clock on the ground. Okay? Which is absolutely not true, and I proved that with my, where is it? I can't find it now. With my, my sand clock, my hourglass. Hourglasses are gravitational clocks. They work only by gravity, and that's the best way to test this theory. And yeah, clocks on the ground tick faster than those on the top. So it's the other way around. And Einstein never figured that out. Okay, but then here we continue. It says also the International Space Station, right? ISS. Astronauts on the ISS have experienced a tiny amount of what? Time dilation. Oh, okay. After several months in orbit, they have aged a fraction of a second less than people on Earth. Let's assume that's true. It's got nothing to do with time. It's got to do with biology, okay? The fact that someone has progeria, right? Caught progeria on his way out. A little boy becomes, is aging. Is he in a time warp, or does that have anything to do with time? Or is that an issue of biology? So this is what you got to figure out. That's why I like the case of progeria, because it defeats this notion that, a person who ages biologically faster has something to do with time. Not necessarily, okay? Could be biology and not time. Okay, but here we have Brian Greene, and he kind of reverses himself. He said, well, maybe we can travel to the past. And so listen to him. He's going to tell you in his own words, right? Here he goes.
There's nothing in the laws of physics that says events have to unfold through the familiar sequence we call forward in time. According to these equations, events could just as well unfold in reverse order.
Yeah, only in mathematics, okay? In mathematics, yeah, you can do all this fancy stuff, this irrational, supernatural stuff. The question is whether you can do this in reality, right? They can do it with the equation. They just put a negative sign in front of the little t, and they get negative time. They can go back in time or whatever, Yeah, you can do that on the equation. The question is whether you can do that even in a lab. These people talk about experiments. Hey, this is time to do your experiment in a lab, right? Show me that you went back in time or went through the time tunnel to visit your grandfather or Napoleon or whoever, right? Okay, but he says the math does not really rule out. The math does not rule out time travel to the past. Okay, listen to him, okay? This is important.
But since the math hasn't yet ruled it out, we can't dismiss time travel to the past entirely.
Okay? So he says it is possible, okay, to go back in time also, not only forward, but also back in time. And so you have the AI, which I consulted, and the AI says, no, you cannot, under special relativity, you cannot go backwards in time. You can only go forward in time. That's what the AI says. But good old Brian Greene overrules him, the AI, by saying in general relativity, we can do it, okay? And general relativity incorporates special relativity. It's just special relativity with gravity. That's all. That's the only difference, okay? Flat land versus 3D land, I guess. You don't have gravity in flat land. Can't fall down, okay? So here it is. Listen to him. He says special relativity itself, well, this is the AI. So special relativity itself does not provide a mechanism for traveling into the past. General relativity, on the other hand, right, offers some theoretical possibilities for backward time travel through what? Extreme conditions like rotating black holes or wormholes. And there you have the wormhole version by Brian Greene and the black hole version by Brian Greene. Wormhole, he goes to see himself in the morning, shakes hands with his own self. And in the black hole scenario, he goes out on a trip, comes back, I don't know, maybe a few years later. He's as young as he went out, but look at the check-in agent. She aged a little bit, right? This was her when she gave him the ticket. And what happened next? Well, he travels out to the wormhole, to the black hole, goes around it a few times, comes back, right? And what happens? She aged. He didn't. Okay? So yeah, they claim that there's experimental proof. According to them, there's experimental proof that you can travel to the past. Maybe not under special relativity, but you can under general relativity. So don't be a special relativist. If you want to become young again, be a general relativist. Okay, that's the bottom line. Well, what do we do with all this? We say you got to throw it down the drain. No, not down the drain. You might dirty my drain. No, it belongs in the city dump. Okay, that's where it belongs. It's trash. It's garbage. It has nothing to do with science, what these people are doing. And so what we do is we destroy time, let alone special relativity and general relativity. We destroy time itself with the universal movie. And the universal movie is a tool I created, okay? Anybody can borrow it and use it to destroy mathematical physics, especially time, anything related to time. It's a useful tool if you understand it properly and you handle it properly. So here it is. I'm going to try to explain it one more time. I've done it a couple times in the past, but here it goes one more time. I hope I don't bore the people who've already heard it. Here it is. Okay, this is the universal movie, okay? This is God's film, the devil's film, whatever you want, Father Universe, Mother Nature. It's a film of of motion in the universe. In a single frame, all you have is location. Okay, every object simply has distance with respect to every other object. That means every atom, every star, every whatever, everything out there in the universe that exists simply has distance with respect to all others and has location only. These are static concepts. That's what's in a single frame of the universal movie. On the other hand, if you want to see anything related to motion, you would need to have all these atoms move to a new location called motion, two or more locations, and for that you need at least 2 frames of the movie. So all the ones on the bottom require at least 2 frames, and the ones on top can only fit in a single frame, these concepts, okay? So that's our starting point. Hopefully you understand what I'm talking about there. I'm saying that every single atom in the universe, whatever's out there, has only location with respect to all others in a single frame of the movie, okay? Now, this bozo, this clown, he talks about, but in the religion of mathematics, he says the time is continuous. Motion is continuous. You know, he's got these notions that he inherited from Aristotle and Plato, all these bozos of the past who, they didn't have the brains to analyze these things. And so let's make sure we understand the following, okay? Every atom in the universe only has location, one location. It does not have two locations, nor does the location get smeared from A to B. Okay, so there's no continuous location between two locations. There's discrete, to use that term. I hate to use that word with concepts, but in order for these people to understand, location is discrete just like an object is discrete. Okay? And you don't smear the object and you don't smear the location from one location to another. Okay? It's discrete. You either have location here or a gazillionth of a gazillionth of a gazillionth of an inch or a millimeter next location. Okay? But location is always discrete. You cannot be at two places at once like in the religion of quantum mechanics. Okay? You can only have one location. Okay, so location is not smeared, it's not continuous, it's not incessant or any of those. Location is discrete, to use that term. Okay, so it's here, and then it's a gazillionth of a gazillionth of a gazillionth next to it where it moved next. Okay, so you can chop up the film as many frames as you want. I don't care how many frames you want. The next location with respect to all objects in the universe is a new location for every object in the universe. Okay? So locations is not smeared, it's not continuous, okay, or incessant or whatever word you want to use in there. But what's the problem? Well, here let's put it in small terms so you can see it there, okay. You have the past, present, and future. Okay, so you have the past, which was the previous frame. Now you have the location right now, whatever now is, right? Now again is the time term, and what we're saying is it's only got location at that point. It's only got location, okay? Existence, which is an object that has location. And then you have the future, okay? But what's the problem with this? Well, there is no real film in the sense that you're seeing it there, okay? What I put there is misleading, okay? Let's put it in the right way so that everybody actually understands, okay? This is what we have, okay? What we have is that all the atoms have moved out of the frame and are now at a different location. The previous location of all these atoms, it doesn't exist. Mother Nature, Father Universe, God, the devil, they don't have memory. They don't keep the atom there for you to go back in time and land there. Okay? Every atom has now moved to the new frame, which is we'll call the present, okay, the now, the cross section of time, the cross section of motion. In other words, location, which is a static concept. And we have not yet gone to the future. Okay, so both the past and the future are blanks. There are no atoms there because one has already happened. The atoms have moved out of that frame. They're now in that middle frame. And the atoms there have not yet gone to the future. They're not there yet. So there is no past and there is no future according to Father Universe. This is Father Universe here. Let me show them to you. Okay, that's Father Universe. Every atom in the universe, right? That's what makes up Father Universe. Father Universe goes to sleep for a gazillion years, and the next second he wakes up, okay? He wakes up, and he checks every atom in his body, and he says, okay, all these atoms are there under a location. They all have location. And then he goes to sleep again for another gazillion years. 1 second later, he wakes up. He looks at all his atoms, says, okay, they're there. He doesn't know where the atoms were before because he doesn't keep a running tab of where the previous locations were. Father Universe doesn't do that. He's an old man and he's been around for quite a while and he's got amnesia. So when he wakes up, all he just cares about that every atom has location. And in the next frame he does the same thing. In the next frame he does the same thing. All the atoms simply have location. And that's Father Universe there, all he has is location. All the atoms have location, that's all he cares about. And location is a static concept, and we don't smear them across from one frame to the next and say, oh, location is continuous. We stretch the location. We stretch the object to the other frame, and then to the other, and then to the other. Or made a clone of the atom. And so here's the atom in this frame, and then we make another clone of the atom in another frame at a different location. That's not how it works. The atom moves, changes location, right? Has two locations, a second location, right? And no longer is at the previous location. So if you want to go to the past and land on the atoms that were there 1,000,000 years, 1,000 years ago, you're going to be disappointed. You're going to be very disappointed because there are no atoms there. They're already in the present. So imagine if you take a ride, right, on your spaceship. Hey, you leave the Earth. You go at the speed of light or faster than the speed of light. We don't care. Every atom in your body is simply changing location with respect to all other atoms in the universe. Okay? So whether you're far, you're near, you go fast, you go slow, it doesn't really matter. Every atom in your body is simply changing its location with respect to all other atoms in the universe. We're all in the present. Okay? It doesn't matter. You cut the film wherever you want. Okay? So this notion of going to the past and to the future is garbage that comes out of the mind, irrational minds of mathematical physics. Okay? There is no such thing as time out there. We don't use time. We use it for everyday stuff. You know, you get late to the airport, you lose the plane. I mean, we know that. But that's got nothing to do with physics, with how the universe runs. The universe only has atoms. Those atoms have location with respect to all others, meaning they have distance with respect to all other atoms. And it doesn't matter how fast you travel, how slow you travel, you can't go to the past because there is no such thing as the past. Those atoms are no longer there anymore. All you're doing is changing your distance with respect to every existing atom in the universe. I hope I made my case. I hope people understood. Some of you. Others, like the clown, he doesn't understand. He doesn't understand squat. Okay, so once again here, let's review. Okay, physics has no use for time. Time describes, physics explains. Okay, what is time? A comparison between two motions. That's what time is. It requires that someone have memory or a recording device. You have to record the previous locations and then compare those locations. Okay, that's essentially what it is. And so what is time? Time, you know, they represent it with a number line. It's not a dimension. It's not a coordinate. It's not a vector. Time has no direction, only has magnitude. And it's, as such, it's just a number line. Now, the problem there is that they always put a little arrow and they put a straight arrow, I guess, right? A straight stick with an arrowhead at the end. And that's misleading because that gives the people the impression that time has direction. Time has no direction, neither does a number line, which is what time is. Number lines don't have direction. You can put numbers in any direction you want because they have no location. Numbers don't have location. 5 minutes doesn't have location. Okay? That's a number that mathematicians put, you know, on a stick, and they call it, 5 minutes, I understand, and it's after 4 and before 6. No, there's no after, no before in the sense of direction. You can put the 4 over here, the 5 over there, the 6 up there, and you can put them anywhere you want. Numbers don't have location. So time is not a dimension. Time is a number line. And when you talk about space-time, you're talking about 4 number lines, not dimensions. Space-time is not 4-dimensional, it's 4 number-lined. Okay? And what's a dimension? One of 3 mutually perpendicular directions an object may face or point. It's strictly a qualitative concept. Belongs exclusively to physics. It does not belong to math. There are no such things as dimensions, coordinates, or vectors in math. All you have in math is number lines. Okay? Let's get that straight. You know, these people call these number lines, they call them dimensions. Oh, the coordinate. No such monster. Not in math. Okay? And yeah, what we have to do, and here you'll see it, we have to define the keywords necessary to give a presentation, a physical interpretation in physics. And you can see I've got several words there that form what I call the foundations of physics. You can't do physics, you can't do physical interpretations without these words. You absolutely need to define these words. No one has ever done so in the last 10,000 years. Especially that first one, object. No physics textbook begins by defining what an object is. Turns out you can't do physics without an object. And no one gets taught that in high school, let alone in college. And as you can see, something's missing there, and it's the word time. Why? Because it's not a key word of physics. We have no use for time in physics, okay? So yeah, we do not use time because time can only describe. Physics is about explaining mechanisms, causes, objectively. Do you believe in the mechanism? If you want to, you can believe in it. You can believe in another mechanism. Let me give you an example. Someone explains that the reason the window broke because a kid threw a rock through the window. Okay, so that's his explanation. That's his mechanism. That's his theory. And another guy said, no. My dog Rover, he jumped through the window. That's how it broke. And then another guy has another theory. He said, no, Joey, your neighbor, he hates you, and he came in with a crowbar and broke the window. So we have three different theories, right? And so people say, well, we need to verify. We need to find out, what the truth is. Well, you don't find the truth in science. Truth is in the eye of the beholder. It's a belief. One guy says this, we'll continue believing it was a rock. The other guy will continue believing it was his dog. And the other guy says it's a crowbar. They'll continue believing whatever they want, irrespective of the evidence. So evidence is there only to persuade people. In fact, you have this fellow now who's, Gilgo murderer. He's going to be tried, I guess, in January or something like that. He killed like 7 women. And the prosecutors, are going to try to, present evidence to convince the jury, to persuade the jury to believe in their side of the theory, right, and in their side of the case. What's the defense attorney going to do? Well, I'll tell you what he's going to. He's going to say, this fellow, Rex Hogerman, I think is his name. No, he was in China at the time, so he wasn't the guy. There's another killer out on the loose. That's what they're going to. They're going to have a different theory. So who's right? Well, we don't care who's right. The point here is, who does the jury believe and who are they going to vote for? That's it. But that's got nothing to do with science. That's not science. That's called religion. It's got to do with belief, with whom you believe, what theory you believe. You've chosen, you've voted. That's not what we do in physics and science. In science, we only explain objectively. This guy says it was a rock. This guy says it was a dog. This guy says it was a crowbar. We have the 3 theories. You can believe the one you want. You can get all the evidence you want and continue believing the one you wish. We don't care what you believe. We don't prove in science. We don't twist arms. We don't try to convince people. We do that anyways because it's human nature to do so. But we have to distinguish that, which is religion, from the objective explanation for the mechanism. And that's what all these people have trouble. I mean, they've been so brainwashed by belief and by proving, verification, falsification, and all this nonsense that mathematicians created, because that's what the mathematicians do. They come to your home with their quantum Bible and they say, we proved it. We ran a test and this is what we measured and you have to believe us. That's the way they operate. And that's not what we do in science. In science, we do not come to your door with a quantum or general relativity Bible and try to persuade you. You can believe whatever you want. We're just going to explain to you a mechanism so that you understand, not so that you believe. Okay? Okay, so here we have our bozo again. Let's put him up there. And he's been criticizing our understanding of the mathematical method, which he calls the scientific method, which has been around for 400 years. His only arguments in the end are democracy, authority, and tradition. He said, we should believe because we've been doing it like this forever. We don't want new definitions. Those are your definitions, Bill, not ours. What do you mean ours? There's only definitions. Either they're good or they're bad. And there's only theories. Either, everybody has a theory. So why accept the ones from the establishment when they're all irrational? And so this is the issue. Okay, so here it goes. He says, Gaede's response is entertaining rhetoric. Yeah, for him it's just noise what I said. It goes from one ear to the next because he's only got a space-time between his 2 ears. There's nothing there, just a bunch of number lines. Warp number lines, by the way. He hasn't addressed any of the previous flaws of the rope model. Yeah, there's nothing to address because we have to look at what physics is, what science is first. We haven't resolved that issue yet. And you can't go in there and say, oh, but this is what the mathematicians say science is, and this is what the mathematicians say been doing for the last 400 years. This is what the mathematicians voted for at the math club. Yeah, we don't care. That's not an argument. You have to have something more than authority, tradition, and democracy. Those are not those are not valid scientific arguments. Okay, and he misrepresents physics and promotes pseudoscientific ideas without evidence or testability. Well, yeah, it's pseudo-mathematical, right? That's what it is. It's pseudo-mathematical. That's what he's talking about. And we don't use evidence because evidence is used to persuade and convince people, and testability is the same thing. You can run whatever test you want in your dark basement. I tell you my theory. You go to your basement, do whatever test experiment that you want to do. No problem. No one stops you. And then you can believe in whatever theory you want. We stop at explanation and understanding. Once you understand the theory, the mechanism proposed, we're done with science. Now you can go and test whatever you want, and believe in whatever you want. It doesn't concern science. It concerns your personal belief. That's all it does. Some people have proven that God exists. The other person says, well, I've proven that God doesn't exist, and who should we believe? He raises valid philosophical questions. Well, thank you. The importance of clear definitions, which mathematics doesn't have. There are no clear definitions in all of mathematical physics. Okay, I'll rebut key points with references to established science, and science advances through what? Peer review and debate. No, science does not advance first through peer review. Peer review is just used for censorship, to reject papers that do not bow down to quantum mechanics and relativity. That's what it's become. And debate, no, it doesn't go through debate. Science has nothing to do with debating. Okay, you can debate all you want, and that helps people think, right? But then that's not science. Science is when someone comes to the conference and explains a mechanism, how gravity works, how light works. Okay, that's what we want to listen to. We want to listen to the mechanisms that people propose. You have the flat earthers, you have the etherists, you have the electric universes. All these people have their different ideas. All are welcome. They should all come to the conference. And this guy explains his theory, the other guy explains his other theory. You're welcome to tear them apart, no problem there. Okay, but you can't say, well, I don't believe in your theory. Well, who cares? I mean, your belief is worthless. Okay, it's got nothing to do with science. Okay, so here we have the scientific definitions that we have today of science. Okay, mathematical method, really. This is the Science Council. One of the authorities on science. And this is their definition of science. Science is the pursuit and application of knowledge and understanding of the natural and social world following a systematic methodology based on evidence. Absolutely not. That's got nothing to do with science. And they got this from, some of these fellows here that from the 17th century. And, they're from the same circus. They're clowns. That's what they are. So let's look at this. No, science is not the pursuit. There's not a process. Science is not a process of, ongoing forever, of discovery and whatever. No. Science is you explain a mechanism. And once you explain it, we're done. Okay? That's it. Technology, application has nothing to do with science. Science is explanation. Technology has to do with developing gadgets by trial and error. One thing has absolutely nothing to do with the other. People think that technology proves theories that, that, for example, that GPS proves that time is warped, that time is a physical object, and computers prove that a particle can be at two places at once. No, absolutely not. Okay, the fact that computers work has nothing to do with particles being at two places at once. The explanation is ridiculous and is irrational. That's how we should call it. Science has nothing to do with knowledge. Knowledge is just belief. It's just a strong belief. That's all knowledge is. That means you believe strongly in your knowledge. And you say, well, I can prove it. Look, I can run it. Yeah, whatever. We don't care. Knowledge simply means that you believe in this and another person believes in something else. He's got a different knowledge. So knowledge is not part of science, only explanation. And that other word that comes after, understanding. That's what science is about. We just need to understand objectively. Everybody can then reach their own conclusion and reach his own knowledge, his own belief, his own opinion. We don't care about it. Okay? Evidence, no, it's got nothing to do with evidence. Science has nothing to do with evidence. Evidence is just used to persuade, convince, convert, and recruit. That's it. That's all that evidence is used for. Okay, and here you have objective observation. So you gawk, okay, and you say, I gawked all day long. Well, the fact that you gawked, does that mean you understood? That you understood what you were gawking at, what you were observing? So no, observation has nothing to do with science. You can observe all you want. When you come to the conference, you need to explain. You don't say, well, I observed. So what? You observed. So far you haven't explained anything. And at the end there, you have censorship. That's what they do. Verification and testing, what's all that got to do with? Well, it's got to do with convincing people again, and with censoring and falsifying, as they call it, verification. And what is all that about? Well, that's about convincing people. That's all it is. That's what verification means. That's what peer review is all about. Peer review is okay if it just checks to make sure that the theory is scientific. And for that, you need to know what science is. You need to define science, and you can't define science on the basis of evidence, because that's not science. That's belief. So we got a problem with the definition of science, and that's what this clown here, he doesn't understand. Okay, so here's a summary of essentially what this fellow says, right? It's a summary by Brian Greene, and I think he does a good job in summarizing what mathematics is about, mathematical physics, okay? Listen to him. Yeah, I think he does a pretty good job of synthesizing mathematical physics, which they call science, right? Here it is. Listen to him.
The laws of physics are the mathematical equations we use to describe everything from the behavior of atoms to the swirl of galaxies. They've been devised and confirmed through centuries of observation and experiment.
What do you say? Authority again. He says, tradition. We have the data. We convinced ourselves, and now we want to convince the world. No, don't convince me. Explain to me the mechanism in a rational manner. I'll convince myself. Don't worry about that. Okay, I'll take care of the convincing part. So this is the problem. The problem is that these people think that physics is about mathematics, doing equations, the measurements, and they say we've measured this for all these years. We have a big tradition of measuring, and we are great measurers, and we continue to measure. And but you haven't been able to explain a single thing. So what's your measurement? What's your equations? What are they worth if you cannot explain why this pencil, right, falls to the floor, right? You cannot explain to me gravity. Something very simple, baby stuff. And no one in mathematics has been able to answer that question in thousands of years, even from the days of the Greeks. Nobody was able to tell you why things fall to the floor. And today they still can't. Okay, so here's my definition of science in comparison. You can compare them side by side. The mathematical method has to do with observation, something they call hypothesis, where they say it's a tentative explanation, predictions, whatever that is, some astrology stuff. They do experiments. What do they do experiments for? I mean, what's the point of an experiment? Is it to convince someone, to convince yourself maybe? Is that why you do an experiment? Then they describe mathematically, they put an equation, right? They invent technology to confirm the theory. They say, the fact that we have the technology confirms the theory. Absolutely not. And then they convince the other mathematicians, what's called proof, truth, etc. And someone else then verifies the measurement. If he measures the same thing, he has either falsified or confirmed, right? Then they win prizes and do the celebrity circuit. Now, that's not science. That's the mathematical method. What we do in science, first define science as rational explanation. That's what they are. And the scientific method consists of hypotheses, which are not theories, tentative theories, or otherwise. They're assumptions. That's what a hypothesis is. It's an assumption. And what are we talking about? We're talking about the objects that are going to play a role in your explanation of your theory, right? Definitions of the critical words that you're going to use to make your case, and the initial scene, what we call the statement of the facts. Not the facts, but your version of the facts, which is a statement of the facts. We're not talking about Mother Nature's facts, which are the true facts. We're talking about your impression, your notion of the facts. And then we go into the theory and explain the mechanisms and the causes. So you can see we've got a little difference with the mathematical method, which is what this clown talks about. And again, he just wants to get through with it through democracy and authority and, democracy, authority, and what was the other one? And tradition, okay? So he thinks he's going to get away with that. He said, well, we've always done it this way. Yeah, we don't care. If you've done it wrong, you got to correct it. And then he accuses me of being a hominid, okay? I'm a hominid. I'm a monkey, I guess. He said, ad hominem attacks and dismissal of criticism. But he says something right, which I modified it a little bit. The crackpot index, right, is a classic ad hominid fallacy, right? Attacking the person instead of the ideas. You know, this crackpot index has been around for quite a while. It's 1980s, I think, or 70s, late 70s, something like that, by this Mexican fellow, John Baez. And he created this thing, and it's in the Riverside University website. Riverside is maintained by the federal and state government. That means you're paying for it through taxes. And these people use the crackpot index to belittle you. But he's worried that I'm belittling, I'm treating all of them facetiously or, smirking at them and making fun, cynically treating them, etc. No, the issue here is I didn't invent this, okay? When I came out with my theory and went to these websites, they used the crackpot index on me. So, I didn't invent this. I'm reacting to what these people do, okay? I have just as much right to belittle them as they have of belittling me. Okay, he said, this undermines rational discourse. Absolutely. Yeah, we don't have a clean, level playing ground. These people have the high ground and they want to belittle everyone who challenges quantum mechanics and relativity, even though the theories of quantum mechanics and general relativity are garbage. They're total trash, and then not one of them survives rationality. Okay, so it's, I think I'm in my right in treating them facetiously and not taking them seriously. Okay, if the critic misrepresents the religion of mathematics, I made a little poetic license there, right? The critic should clarify without mockery. Absolutely. That's the way it should be. That's not the way it is, okay? The mathematical establishment assumes malice or incompetence, which poisons the well and discourages engagement. Absolutely. And I tell them, you forgot, censorship. They also censor, okay? They censor through their peer review system. They will not allow other ideas to make it to the public, especially to the public. And you say, well, why should they? Well, why not? I mean, why not have all ideas let people decide for themselves? You propose ideas. Why do they have to be censored by the mathematical establishment? And that's what's happening today. They say, well, you got to come through us, through our peer reviewers. Okay, so you go through there and they say, where's the equation? This is not an issue of equation. I'm giving you new ideas of how this universe works. Why am I not allowed to present a different qualitative theory that has nothing to do or that, is unrelated to math? That's not the question. The question is, why does this pencil fall to the floor? I don't need any math to explain that. So why do I need to have an equation to explain what causes this to fall to the floor downwards? And so this is the issue. These people say, we want an equation. And if you don't have an equation, we will not allow you to publish. In other words, to reach the public. That's the issue. So they control, they have the key to the city. This is the problem. So they do censor, and they censor through their peer review system. And so here you have this crackpot index that I mentioned a second ago. And again, this is used against people, and it's used by a website that is funded by the federal government. And here it is. This is the crackpot index at California University at Riverside, right? And here are some points. It's like 30-some points that this fellow John Bias mentioned. Here's a couple of them, and see if they apply to quantum and to general relativity and to mathematical physics in general. 10 points for each claim that quantum mechanics is fundamentally misguided without good evidence. So what evidence am I going to present, and to whom? To the peer reviewers who believe in quantum mechanics? Okay, so how am I going to get to criticize quantum mechanics if I can't get my paper published because the peer reviewers are all quantum mechanics? Okay, then we have 10 points for pointing out that you have gone to school as if this were evidence of sanity. So that applies to all mathematicians. They've gone to school and they say, oh, I'm a doctor. See, the first thing they ask you is for your credentials. And they offer theirs without you asking. They say, oh, I'm a doctor. I'm a PhD. I studied 10 years mathematics at the university. So they think that, that because they studied, they're smart. And they come up with the most irrational, ridiculous theories that you can imagine. 10 points for each new term you invent and use without properly defining it. Well, that applies to every word in mathematical physics. I mean, they don't have a definition for time. They don't have a definition for energy. They don't have a definition for field. They have no definitions out there. Or they use them inconsistently. In the case of field, it's defined as a value at each point in space. Okay, so we're talking about numbers, right? Values, magnitudes, numbers, amounts. And then they say, well, the field moved or the field vibrated. What do you mean a field vibrated? The numbers are vibrating? So they either use them inconsistently or never define them. They don't have any idea what energy is. They have no idea what time is. And so, yeah, they get 10 points off for each word that they invent. Okay. Then they have for arguing that while a current well-established theory predicts phenomena correctly, it doesn't explain why they occur and fails to provide a mechanism. Exactly. Not a single mathematician can explain why. They cannot explain a mechanism. That's the problem. And he says you get points off for arguing that you cannot explain. Oh, we'll take 10 points off you because you say we cannot explain. I love that. Yeah, it should be the other way around. The 10 points should go against the people who cannot explain. Okay? And it says 10 points for claiming that your work is on the cutting edge of a paradigm shift. Well, when we get to the black hole today, we'll see all these people who claim that they're at the verge of a paradigm shift because we got new physics and they have all these big headlines. So this applies exactly to them. They get 10 points off for each claim, right? 20 points for every use of science fiction works or myths as if they were fact. That applies to all of mathematical physics. So, I mean, they're going to lose a lot of points there, at least 1,000, I would say. And then 20 points for talking about how great your theory is, but never actually explaining it. Exactly. They never explain because they don't have explanations. Okay? So this is the problem. These people don't have explanations. And this fellow doesn't understand that. I tell him that there are no explanations. Yeah, we explain. He thinks that when they use the word field or the word energy, he has explained. Or time, right? No, they haven't explained. You can't use those words to explain because we're talking about a physical interpretation. For physical interpretations, you need physical object. You need objects. You need things. You cannot use concepts as objects and say, oh, the field moved the charge. That's an irrational statement in physics. It's okay in mathematics, maybe, but not in physics. Okay, you can't use the word like that. You can't say you're transferring energy or transferring information. No such monster in physics. You can transfer a rock, you can transfer a tree, you cannot transfer information or energy. Or you can't move a mass, you can't warp time. All the language of mathematical physics is trash, it's garbage, it's shit. Okay? So this fellow says, Bozo Wright says, bgaede claims physics is only qualitative. Absolutely. Explanations. Right, that's all it is. Physics, because that's objective, that's neutral. No opinions. You just explain the mechanism, say, this is how this worked. This is how the window broke. I threw a rock through the window and the window broke. You explained it. Okay? You can't, then if you have a different theory and you say my theory is worth more than yours because I believe in mine and I don't believe in yours, well, those are opinions. Okay, and you might say, well, the evidence points to my side of the case. Well, we'll let the jury decide that, and everybody reaches his own conclusion. Some people will continue to believe that the rock broke the window, and others will believe a dog jumped through the window. I mean, so they're talking about belief. They're not talking about mechanisms, objective mechanisms. They're talking about subjective beliefs, the interpretations that people believe in, the theories they believe in. Okay. Talking about me, he says, dismissing math as mere description. That's all math is. Math can only describe, has no power to explain, to tell you what exists. Okay? Math can only describe. It's a descriptive language, and it's even more narrow. It's a quantitative descriptive language. It's not qualitative descriptive. Okay? This is backwards. Math is language of physics. Who said that? Whoever told you, is Chinese the language of physics? Is hieroglyphics, Egyptian hieroglyphics, the language of physics? I mean, who said that math is the language of physics? Where did you get this? He's just throwing tradition, what the 17th centuriers did. They said, oh, math is the language of physics. In fact, Galileo was one of the guys who said that. And this guy just bought it and says, okay, if that's the language of physics, that's the language of physics. And he just accepted it. I reject it. I don't accept that math is the language of physics. Math has nothing to do with physics if physics is about explanations. That's why we need to find out what physics is about before we can say that math is the language of physics. Okay? Because it enables precise, testable predictions. Who said that predictions and precision have anything to do with science? What does precision and what does prediction have to do with science? So you predicted, okay, my horse is going to win instead of yours. You made a prediction, okay? And maybe your prediction comes true, maybe it comes false, maybe I continue to believe in what I believed before the prediction came true and ascribe it to or, attribute it to other causes. I mean, predictions have nothing to do with science. Testable has nothing to do with science. We need something objective that is equal for everybody on earth. That means that you explain a mechanism, everybody understands the mechanism. There's no opinion so far, no testing, no experiment, no belief. All we have is a mechanism. People understand the mechanism. Everybody goes home. Some run tests, some run experiments, do whatever you want. Some do some thinking, and then everybody reaches his own conclusion. Those are beliefs. We don't care about beliefs in science. That's religion. In science, we only care about understanding the mechanism so that we understand it, and then everybody can reach his own conclusion, run his experiments, do his own thinking, whatever. Okay? And then he says, for example, Newton's law of universal gravity. I love this one. Force equals gravitational constant G, M1, M2 over, really it's distance squared, but he doesn't know that. He doesn't understand that. Explains why the pencil falls. No, that does not explain. That's not a mechanism. He's saying that the equation explains. Absolutely not. That's called a description, but he thinks that's an explanation. And this is a big problem in mathematical physics. A lot of people think that is an explanation when it's not. Mathematical physics in its entirety has no explanation for gravity. So this is not an explanation for gravity. Okay? But this is what he thinks. He says, via quantifiable attractive force. Force is not, attractive force is not an explanation. That's what we need to explain. Why is a force attractive between masses? But he doesn't understand it. These people are so brainwashed. They're so hypnotized by all the stuff that that they fed them at the monastery that they actually believe they have an explanation when they don't. Okay, so let's find out what the difference is. Here's an explanation versus a description. Okay, explain versus describe. Explain we do in physics, describe you do in math. And it's a description that only is quantitative description. Okay, explanation, causes underlying a mechanism. That's what an explanation is in physics. Okay, we're talking about physics here. Okay, synonym, theory, physical interpretation. You need objects to explain a theory in physics. You need to have objects. You have to move objects around, things. Okay, physics is done with objects. Mother Nature, Father Universe, God, the devil, they all work with objects. They don't work with concepts. They don't move concepts around. Say, I'm going to move the energy in that direction. I'm going to move the mass and the bend time or whatever. That's not the way, Father Universe works. They don't work with concepts because they did not invent the concepts. They only work with objects because this is what the universe is made of. Okay, objects, things, atoms, and it's us who invented the concepts, the relations. Okay, so we talk about moving concepts. Father Universe laughs at those people who move concepts. And what's a mathematical description? Motion of reified concepts. That's what they do. They reify concepts. They turn field into a physical object because they think it's a physical object. They begin vibrating it, and then you ask them, what's the definition of field? Oh, it's a value at each point in space. So the question is, he said quantifiable attractive force. Does a quantifiable attractive force explain the cause underlying Mother Nature's mechanism of gravity? That's the question for you to analyze. And the answer is no. Okay? Absolutely not. Okay, so here we have two cases, how the mathematicians explain versus how a physicist explains. Here's a physicist, okay? This is how a physicist explains, okay? Here you have good old Felix. He waves around a horseshoe, throws it, breaks the window, okay? So now you ask the kid, or you ask anybody out there with two fingers of brain at least, right? Thickness. Say, how did the window break? And the way normal people, normal humans would explain this, say, well, Felix waved a horseshoe around, apparently made out of metal, and he threw it, and that's how the window broke. That's how you would explain it to a judge, for example. If you had to explain something like this, that's how you would explain it. Very simple. That's the way a physicist talks. Now let's find out how a mathematician talks, how he explains it, okay? So here we go, okay? He says, we take a mass, and I had so much energy, threw it so much energy, and the force went through the window. This is how a mathematician talks, okay? And so they say, I explained it. No, you didn't explain anything. You took a mass, you had so much energy, and the force broke the window. What kind of nonsense is that? This is not language that a rational person uses. Okay, this is just garbage that the mathematicians invented. These words which they reify, they turn them into physical objects, and they begin to throw them around, move them around, vibrating them and whatever. No, those are not explanations. Okay, that's why these people don't understand the difference between an explanation and a description. Okay, and then, they harp on evidence also. Here you have the bozo again. He says, concepts like space-time curvature are supported by what? Evidence. Who cares? Evidence for whom? For the Dalai Lama? For the Pope? Who did you convince with this evidence? What was the purpose of the evidence if not to convince? Gaede's ropes are without evidence, hopefully, right? Because they're invisible, intangible. You can never find evidence for something which is invisible and intangible. So I don't know what kind of evidence he wants. I mean, hopefully anyone who explains gravity, right, has to have an invisible, intangible mediator, because that's what Mother Nature has out there. If you say, I went to the lab and I touched the mediator of gravity, or I saw the mediator of gravity, we know you're lying, because the mediator of gravity is invisible and intangible. You can pass right through your hand, right underneath a falling object, and you will not touch anything, or above it for that matter, right? So, yeah, whatever gravity is, it's invisible and intangible. You cannot find any evidence for it. So this fellow is looking at the wrong way. He say, I want evidence. What do you want evidence for? To believe? Is that why you want evidence? His rope model is unfalsifiable, hopefully. Hopefully it's unfalsifiable. Yeah, you can't falsify or unfalsify it because you cannot touch it. You cannot see it. Okay, so what are you going to falsify? And unfalsifiable or falsifiable means that you just believe or disbelieve. That's all it means. By his own admission. Yeah, absolutely. Violating what? Mathematical method standards. I kind of edited his word there, okay? He dismisses evidence, yes, while demanding explanations. Absolutely, that's what you have. You need to have explanations without evidence. But mathematics integrates both. Oh, they do, huh? Evidence is objective, okay? Objective? Evidence is not objective. Evidence is in the eye of the beholder. What is evidence of God's existence to you is evidence of the contrary to the atheist, for example. Replicable and falsifiable, and not faith-based. Yeah, evidence is only faith-based. Evidence only has to do with faith, with belief, nothing more. Bgaede is insistent that science is only rational explanation without math or evidence is anti-mathematics. Absolutely. Yes, thank you. Anyways, explanations must be testable. How do you test an explanation? An explanation is objective, not testable. Okay, you want to test it, you can go out and do whatever test you want. You can run any experiment you want to convince yourself and those who believe like you. You can run any test that you want. Nobody's stopping you. That doesn't mean the explanation is objective. When I say I threw the rock through the window, that's an objective explanation. And you say, well, I don't believe you. Yeah, well, I don't care if you believe me or not. That is an objective explanation for how the window broke. Okay, this guy is saying, well, I don't believe you, and because of that, you're wrong. No, for you, I'm wrong. For me, I'm right. And for my neighbor, he says I'm right too. So, testable only goes towards belief. It has nothing to do with the objectivity of an explanation, of a mechanism. Theories must make risky predictions that could be disproven. No, absolutely not. Theory has to do with a past. It has to do with an explanation. You want to prove something to yourself or to your buddies? No problem. Go ahead and do whatever you have to do. Stand on your head and, knock yourself out. No problem. But, the theory is only an explanation of how, for example, gravity works, how light works, how magnetism works. Real physics explains. Absolutely. That's what real physics does. That's not what mathematics does. Mathematics does not explain. That's the problem. Why pencil fall, curved space-time, or gravity fields? Yeah, so the issue here is that there are no explanations in mathematical physics, and that's the whole problem. And you say, well, where does this guy get his information? I mean, where did he go to school, or what monastery did he come out of, or nut house, Well, here he sends me to his guru, his teacher. He said, this is his guru. His name is Floathead Physics. I'd rather think of him as Flathead Physics. And this bozo, another clown from the circus, all he does is just regurgitate the establishment. And he goes with all these videos that say, I never understood why until now. And they all go the same way. And he doesn't understand squat anyways, and because there are no explanations. That's why he cannot understand. So Flathead Physics, he really has a problem, because all he does is regurgitate the establishment. He claims to understand, and there are no explanations in the establishment, so how could he understand? And you say, Bill, is that true? I mean, are there no explanations? Hey, let's hear it from the horse's mouth. Here's Richard Feynman. I'm sure he outranks Flathead there, or Floathead, or whatever. And he says it clearly. He says, the more you see how strangely nature behaves, the harder it is to make a model that explains how even the simplest phenomena actually work. So theoretical physics, has given up on that. Okay, theoretical physics doesn't do explanations. Yeah, they don't do that. They say, in fact, they dismiss it as philosophy, as metaphysics, as word salad, ontology, whatever they call it, They don't do physical interpretation. They believe that's not part of their job. They think that physics, as they call it, physics, mathematical physics, mathematics, is only equations, only descriptions, mathematical description. And then they follow that up with an irrational explanation, and they say, well, don't listen to that anyway. Don't take it literally, because we don't do that anyways. So why did you attempt it if you don't believe in your own explanation, if you don't understand your own explanation? And here's another fellow. His name is Don Simonek. He's I guess you could call him a professor. He's emeritus from Lock Haven University, and he says, science doesn't explain. Science describes, meaning mathematics. That's what he's talking about. He's talking about the religion of mathematical physics. They only describe, they do not explain, because all the explanations of mathematical physics are irrational. Not one survives rationality. Okay, so this is the issue. And all I can say to this fellow, as well as any other challenger that comes down here, this is all you got to do. And this is very simple. This is, hopefully everybody understands it. This is kid stuff. I think only irrational people would not understand what I'm going to say next. And here it is. This is all you got to show. Okay? Let's make sure we understand here, because physics is done with objects, with things. You can't, the universe would not work if there were no things out there. So you had better have things when you do physics, when you do physical interpretations. And here's the first one. Okay? This is light. You have to explain three things, which the rope model that we propose here can explain, and no one in mathematical physics can explain the same three things. One, the speed, why light is so fast, why it's so swift. Okay, that's the first one. Why is it so 300,000 kilometers per second? That's the first one. The second one, why is it a constant speed? Why does light travel at a constant speed? Okay, and the rope model explains it. Certainly you cannot explain it with waves or particles, even assuming those were valid objects, which they are not. A wave, as you can see there, it's what does it have? A bunch of vectors, which are those arrows that you see there, and they're surrounded by these curved lines, which are the fields. And what are vectors? Well, just magnitude and direction. What is a field? There you see it, a value at each point in space. They're numbers. So what you're staring at is a pictorial representation of numbers, which is irrational, because what they're doing is putting arrows instead of numbers, and people think, oh, I'm looking at arrows that are moving or whatever. No, what you're staring at is numbers, but they put arrows because if they put numbers, you would say, well, what the hell is that? Yeah, you would not understand what that is if they put numbers. So if you replace all those arrows with numbers, I think I'll do that next time, just to show people what kind of idiocy you're staring at there when you look at a wave, right? A transverse wave that these bozos such as Augustin Fresnel and James Maxwell created. Okay, this nonsense is poppycock, which is a pictorial representation of numbers. That's all it is. But, so that's not a physical object. That's the first problem. And photons, the particles that they invented to get through with quantum mechanics, same thing. They had to give it magical properties. You have these quantum particles, or mathematical objects as they call them. And what are those? Well, they're not classical. And by that, they mean that they have special properties, like, they can be at two places at once. And this one can affect that one without any intervening medium. And so, yeah, they have all these wondrous supernatural qualities, so those don't qualify as anything. You can explain anything with angels and with spirits. Right, so you have to explain that. First, you have to explain the speed of light, why it's so fast. The second one, why frequency is inversely proportional to wavelength, which is well established, right? And then the other one, you have to explain why you don't add the speed of your car to the speed of light. When you're running down the highway and you have your headlights on, it doesn't matter how fast you travel. You don't add the speed of your car or of the train or whatever to the speed of light that comes out of your headlights. And the question is why? Einstein realized that was the case. I don't think he was the first one, but he realized that was the case, but he could not explain it. To this day, nobody can explain it in mathematical physics. So we can explain all these three things with our model. They cannot explain it with their model. So what is their model worth if they cannot explain these three essential things that we know about light? Okay. Here's gravity. This is the next one you got to explain, okay? And we have the versions of the establishment, okay? We have the wave version for an astronaut falling to the Earth. How does a wave do that? How does a wave create, this attraction towards the center of the Earth? How about particles? How do particles work? Give me a mechanism for how particles help the astronaut fall to Earth. Either pull or push, whichever one you want. We need a consistent theory. Then you have the number lines of general relativity. Do we slide along number lines? Is that why the astronaut falls to Earth? Whereas the ropes is very straightforward. Every atom of your body is bound to every atom on Earth. Every atom on Earth bound to every atom of your body. And so the reason you fall is that the ropes fan out. We have a mechanism. You may not like it. I don't care. We don't care about whether you like mechanisms or not. We give you a physical mechanism. You reach your own conclusion. We don't care. But certainly the mathematical establishment does not have an explanation for gravity. Okay, not a rational one. Because again, they're using number lines. They're using particles that aren't particles. They're using waves, which are not physical objects, etc., etc. So they don't have a mechanism. Here's magnetism. Okay, you have to explain this as well. Okay, so what's the rationale, you can call it that, from mathematical physics? They say, well, you have these electrons, and they spin in each side of the magnet. Okay, no problem. I don't care which way they spin, if they spin clockwise or counterclockwise. How does the fact that discrete electrons are spinning, each one in their own magnet, how does that produce an attraction from the other magnet? From a distance. So you get to explain. They say, well, it's the field. Well, you can't use the word field because field is a bunch of numbers. It's a description. So you can't say the field does it, and because the electrons are spinning over here in such direction, the field then attracts the magnet. No, you can't say that because a field is a concept, a mathematical concept. You need to put a physical object. You have to show me how this electron bead thing is in contact with the other electron bead thing. Okay? There's got to be a connection. If there's no connection, you're doing black magic. You're doing witchcraft, or what we call voodoo physics. Ours is very simple, straightforward. You have all these threads, which form the famous field, magnetic field. They're threads, not fields. Okay? You have these threads, gazillions of them. They form this so-called field, and you can see if they're going clockwise, both clockwise, they attract. If they go clockwise against counterclockwise, they push each other away. Straightforward. It's a physical mechanism. Babies can understand this. It's straightforward. Do you believe in it? We don't care. We just want you to understand what we're proposing. That's it. That's all we do here. We don't go with our quantum Bible to your house and say, you have to believe because we've proven it, we've measured it, and the Nobel Prize stands behind us. You know, they have all these nonsense answers because they cannot explain. That's why. Here's electricity, okay? This is the other one you got to explain. You have this positive and negative. Nobody knows what that is. Nobody can explain positive and negative in physical terms. What do we have? We have clockwise and counterclockwise. And what you have when you close the circuit, they twirl, the whole thing twirls. Nothing moves from one end to the other, and what you have is simply clockwise and counterclockwise rotation of merged electron shells. Okay, so we have a mechanism, they don't. All they have is these little balls, and some of them disagree. They say, well, the balls are not really moving, and they have all these different theories. After 100 years, they still haven't figured it out. But what they cannot explain is the positive and negative. That's the issue. Okay? So whenever they explain positive and negative in physical terms, maybe we have a mechanism, okay? Which is what we're trying to get to. And finally, we get this quantum jump, okay? And the quantum jump is ridiculous for quantum mechanics because they have this planetary model where the bead, the electron bead, the blue one there, jumps between orbitals or between energy levels, right? So it jumps back and forth, and by doing so, it releases what they call these waves, the energy, whatever they call it. Okay, it's all garbage. It's all trash. That's what all of quantum is. What you have there in atom that is ridiculous because they cannot explain why that bead doesn't fall to the center of the nucleus of the atom, right? Because the nucleus is positive, the electron bead is negative. So why doesn't the electron bead fall all the way to the center? Why doesn't it spontaneously leave the atom? Well, they cannot explain that. They never have. Okay, and they say, well, it just goes back and forth, and for some reason, when it does that, it releases energy or waves or whatever nonsense, frequency. And in our case, it's very simple. The atom is really a ball. Okay, think of it as a ball of yarn encapsulating a proton star. That's what it is. Okay, and so it pumps back and forth. Those are the energy levels that they've talked about. It's not a little bead that goes back and forth, but the entire balloon that expands and contracts. By doing so, it torques the rope, okay, and sends the signal to the other atom at the other end. Period. We have a physical mechanism. Do you believe in it? We don't care. We just want you to understand what we're proposing. We are consistent with experience, and we have a different interpretation, which is not allowed to be published, okay, in the peer-reviewed journals, in the peer-review, even though I have published, but that's aside. It took me a long time to push it through. It's a long story. Okay, so there you have it. That's what these people have to prove. This is what they have to do. They have to produce a mechanism. And, these are straightforward, basic mechanisms that any theory should be able to explain. They cannot explain it. And so they don't have mechanisms. They have irrational things, reified concepts. And they say, it's the field, the energy, the mass, the time, We cannot explain with those words. You need physical objects because Mother Nature doesn't understand concepts, neither does Father Universe. They work with objects. They push one atom or one object from one location to the other every single moment of the day. Okay, so let's go to the main course. And by the way, keep your questions till the end. Okay, if you have any questions that about today's lecture or anything really related to physics or to extinction, you're welcome to raise it at the end of the lecture here today. Okay, so what do we have? Well, what did I put out there? I put out these yellow headlines from the yellow mags. Okay, here it is. Okay, space, the biggest, the smallest, the farthest, the closest, the heaviest, the lightest, black holes. Is this science? Is this what science is all about? Just size and distance and, how old a black hole is? I mean, we see this every day. People gotten so tired of this thing. They're so bored with all this nonsense that, people have lost interest in physics and in science. That's where the tragedy really is. People have lost interest because they don't understand squat. And they hear the same thing every day. We've been hearing the same thing for the last 50 years. They've made no progress in quantum mechanics. So now they try to move over to string theory in one direction, and then they moved into the quantum field theory in the other. They abandoned the quantum. They have fields which are extended concepts instead of the quantum, which is supposed to be a discrete concept, right? Okay, so this is it. This is where we start. And what should I say? Well, I guess my lecture is over. That's all I had, right? Terrible headlines, yellow mags. Well, let's continue. Here you have the famous black hole picture, okay? I think you've seen it a billion times out there. Black hole, an object. No, it's not an object. What you're staring at is not an object. So heavy, it's constantly crushing itself into smaller and smaller object, and it does this faster than the speed of light speed. So there you have it. Is that a black hole? Absolutely not. What are we staring at, okay? What are we looking at? That's what I want you to tell me, okay? Are we staring at a black hole? Well, let's find out. Let's go to NASA. NASA can tell us unambiguously what we're staring at. And here it is. What they're telling you is that what you were staring at just a second ago is really, something that's circling a center of some kind. So you have this black center, and there's something circling. Okay, so what you were looking at is kind of like a drain. Okay, you were not looking at a black hole, but what is rotating around a black hole. That's allegedly what they took a picture of, and it's not a picture like a snapshot. What they did was they did a composite. It was, they took pictures from different sides and they made a composite of that, of what they called the black hole, and that's more or less what you're seeing there as well. So you see something in motion, first of all, and second, what you're seeing is stuff circling a center. That's what the picture shows. Okay, so you're not taking a snapshot of a black hole, which is what a lot of people think they're staring at. That's not what you're staring at. What you're staring at is a snapshot of allegedly something which is circling a region of space out there, right? So what you're looking at is this. You're looking at a drain, okay? That's what you're staring at, okay? And you're looking at not the drain, You're looking at the stuff that's circling the drain. That's allegedly what the picture shows, right? Okay, so is there a drain? That's the question, because that's supposedly the black hole. The drain itself is the black hole. Okay, and I prefer to look at it rather than as a drain. I prefer to look at it as a toilet, which is, I think, where all this stuff belongs. So there it is. I think it should look more like this, right? Toilet, and I forget to put the brown stuff in there. But this is, I think, what where the black hole belongs, okay? This is what I think it is. It's a bunch of trash. That's what it is. I wouldn't even throw it into city dump because I don't want to mess up the city dump, with all this garbage that comes out of mathematical physics. Okay, so here's the black hole from NASA. This is what they think it is, and I liked it when I went in there. It says, due to the lapse in federal government funding, NASA is not updating this website. Absolutely loved it, and I hope they continue removing funds from NASA, especially from all the idiots, the mental retards who talk about relativity and quantum mechanics, but mainly general relativity and special relativity. We need to get rid of all these people from positions of power. They don't belong there. They talk trash. That's all they do. That's all they've put out there. It says black holes are mysterious cosmic objects. Absolutely not. They're not objects at all. Okay, much studied but not fully understood. Yeah, they don't understand it because it's a concept which they reified and turned into an object. That's what it is. These objects aren't really holes. Oh, no kidding. Yeah, because a hole is a concept. So what is this thingy you call a black hole, a singularity, or whatever you call it? They're huge concentrations of matter packed into very tiny spaces. In other words, they're saying that we're talking about a ball that's got a lot of matter compressed into this little tiny ball, this golf ball or whatever, right? Gravity just beneath its surface, the event horizon, right, is strong enough that nothing, not even light, can escape. Okay, so they're talking about an event horizon, but they say the event horizon isn't a surface like the Earth's or even the Sun's. It's a boundary that contains all the matter that makes up the black hole. A boundary of what? It's like I like to use the analogy of a campfire. The campfire, the heat goes to a certain extent. And you can say that the extent where you can still feel the heat to some degree, right? We'll call that the event horizon of the campfire. Okay, so you have this surface, which is not a surface. You can't stand on that surface, on the surface of temperature, right? But that's more or less what they're explaining. And I like it says they don't understand much about black holes, right? But the issue is that think of it as a campfire, right? You have a campfire, and the heat goes to a certain extent. Okay, so you go far enough away that at some point you can't feel the heat. Okay, and we'll call that the surface, the event horizon of the campfire. That's essentially what a black hole is. So you can't stand on this surface because it's not a surface. What it is the extent to which the heat reached, and in this case you're talking about mass or gravity. It reached up to a certain point, up to the event horizon, which is where the speed of light, changes, right? Okay, so this is the issue. The issue is that we're talking about the event horizon is not a physical object, and it encapsulates a campfire that ain't a campfire. In other words, there's no logs there. There's no real fire going on there. What it is, you have all this matter coming to a center ball, and somehow it produces this aura, this ghostly spirit known as the event horizon, which is the separation between the surface of where gravity still is strong to the center of this thing, which they call the singularity. Okay? So we need to understand a little bit of what a singularity is. What is a singularity, and why does it extend its gravity all the way to the edge? Why is there gravity there? I mean, if you happen to be close to the event horizon or across the line, why are you attracted to the center? What's coming in physical contact with your body? I mean, is this done by angels? Is this done by spirits? How is it that your body is attracted to the center of the black hole called the singularity? Why? What's coming in contact with your body? That's the question that we're asking. It better be a physical object, okay? And so we need to know how the black hole is created, how it originates. And according to these people, they say it's a star that collapses upon itself like that. Okay? And so it collapses and it reaches a tiny little point called the singularity. That's the black hole, and it's surrounded by an aura of gravity, we call it. And that aura is a concept. They just say that's as far as gravity reaches, so that you have this speed of light border, right? That's it. That's all it is. And that's only one way they create black holes. Then they say they have more massive black holes when one black hole eats another black hole and another black hole and another one. And so that's how they get to billions of masses or billions of suns, as far as mass is concerned. That's how big these things are, according to these folks, okay? So one of the problem here is that, is there any matter at all alive between the event horizon and the singularity? Is there matter there at all? Are there atoms still there? And you have all these people, all these are registered mathematicians, and they claim that matter is completely crushed out of existence. Okay, there you have several of them: Cole Miller, University of Maryland, Craig Wheeler, etc. And you can go down and you'll find them all saying that it's crushed out of existence, all matter. There is no matter inside a black hole. So we have a contradiction, because some people say that it's all a little ball of crushed matter, of compressed matter, and these people say no, matter is completely crushed out of existence. So which is true? I mean, is all matter crushed out of existence, or is there a little ball there that weighs a lot? And either way, again, you got to explain how that ball, assuming here's the ball, here's the singularity, or the little ball at the center. I guess I don't know how else to tell you. Okay, so here's the ball. Okay, it's got a lot of mass, a lot of matter crushed into this little ball. Fine, no problem. It weighs gazillions of tons, this ball, right? Because it's got all this matter crushed in there. No problem whatsoever. Okay, now how does it affect me? How does that ball come in contact with my atoms and pull me towards the ball? That's what you got to explain. A mechanism. Give me a mechanism. Okay, don't tell me it does, that you measured, that you verified and proved and falsified and whatever. No, tell me the mechanism. I need to see a mechanism of how the ball pulls on me. In other words, how does a black hole pull on a star that's thousands of miles away? How does it do it? How is it pulling on that star and forcing it to go around in circles around itself, or pulls flay it alive because it's pulling the skin off of this star? So how does it do it from afar? We need to find out a mechanism how the black hole interacts with physical objects that we can see. If you cannot explain the mechanism, you don't have a theory. Period. You're done. And so here's two versions. Hold it. Here we have the gravitational singularity is a theoretical condition in which gravity is predicted to be so intense that space-time number lines would break down. Number lines, I put that in there, by the way, would break down catastrophically. As such, a singularity is by definition no longer part of the regular space-time number lines, right? Because that's what they're talking about. They're talking about space-time. What is space-time? For number lines. That's what space-time is. And so they're talking about warping or catastrophically breaking the number lines, whatever that means. What does that have to do with physics? I have no idea. Or with reality? I have no idea. And says gravitational singularities exist at a junction between general relativity and quantum mechanics. Therefore, the properties of the singularity cannot be described without an established theory of quantum gravity. So they don't have a theory, they don't have a definition really of the word singularity. They've been with the word singularity now for 100 years, over 100 years, and they still cannot define the term. They don't know what a singularity is. It's the core of a black hole. They're all looking for it. They all prove the black hole. It's been confirmed. It's been falsified, verified. And it turns out that they don't know what a singularity is, which is the core of black hole. Trying to find a complete and precise definition of singularities in the theory of general relativity, what remains a difficult problem. Now, it's impossible because, here they've been over 100 years. They don't know what a singularity is. Singularity in general relativity can be defined by number line curvature, because that's what they're curving there. they're curving number lines. And they say they become infinite, whatever that means. So they're stretching this thing to infinity, and they say that's what a black hole does. It stretches the number lines all the way to infinity. What kind of nonsense is that? What does that have to do with physics, with reality? So this is the problem. They cannot define the singularity. And so what I like to do is, this is a good time to bring good old John Bias back into and help us out with this. And he says, crackpot index 14, 10 points for each new term you invent and use without properly defining it. Yeah, good old John Bias, he criticized all these people. They say, hey, you haven't defined what singularity is in 100 years. So what chances are that you will define it in another 100 years? I don't think so. And so these are the notions they have of what a singularity is. Okay, some people think it's a tiny ball of matter. Others think it's been crushed out of existence. All remains is a hole. But a hole in what? I heard of a hole in one, but never a hole in nothing. And that's what the singularity is, a hole in nothing. And you have all this matter that's falling forever towards the singularity, but never makes it to the singularity or through the singularity, because the laws of physics break down at the singularity. That's the answer you get. What do you mean the laws of physics break down at the singularity? What does that mean? Well, the equations get all these infinities. In other words, the matter always falls, it never makes it there. So it's still between the singularity and the event horizon. And then you have these other bozos who said, no, matter is all completely crushed out of existence. So which is it? And others say, it all is compacted into a ball. So which of these is true? Please tell us, mathematicians, which of these different versions is the correct one. Will the real singularity please stand up? So this is the problem. We don't have a definition for singularity. We don't know what a singularity is. We don't know if the black hole contains matter between the singularity and the event horizon. We don't know if all the matter has gone crushed out of existence, meaning it went through the singularity. And so we don't know what a black hole is. But assuming we knew and we had the singularity, down pat, like let's assume it's a ball, or let's assume any of them, I don't care, just a bunch of mass. How does that affect a star far away? How does it tell me the physical mechanism? Don't tell me that it's got a lot of mass, because that doesn't explain the mechanism of how it attracts or influences a star. That's what you got to explain, the mechanism. If you don't have that, you don't have a theory. You have this garbage mathematics that has no validity in physics. It has no place in physics or in science, for that matter. So yeah, we come back to the yellow mags there. This is what they talk about: the biggest, the closest, the farthest, the heaviest, the oldest. This is it. This is what we get. This is what they call science out there. And people have gotten so sick of it that people don't care anymore. They don't care anymore about physics, and that's where the real crime has been committed. Okay, I'll open the floor up for questions. Give me like 10 seconds between the time you put the question and I answer it, okay? Because transmission is not instantaneous like gravity. Give you a minute there. Anyone who wants to ask questions can go ahead. I'll do my best to answer them. Otherwise, I'll give you a rain check, okay? One fellow says, in ionization, how can the whole shell spin in one direction if the ropes that form the atom are reaching it radially from all directions? Each rope rotates on a different axis. Well, keep in mind that when you have a rotation, it cuts across the rope. You have to remember that at that level there is no touch. Touch is what's killing people. People say, well, how do they touch? How do they go through? There is no touch at that level. Touch comes into existence as an emergent property at our macro level, at two places at least that I can safely tell you. One of them is the ball known as the atom, the electron shell or ball of yarn encapsulating the proton star. Now you have a surface for the first time. That's when you have touch. Now an atom can touch another atom. Until then, you don't have touch. And so that's what kills people. They say, we have a rope coming towards the ball. How can this thing rotate and the rope is, ending there? Well, it cuts across the rope. I know it's difficult for us to understand on our level, but that's the way Mother Nature runs her universe. We have a weird universe because at her level, she doesn't recognize touch. And yeah, it's a killer for the brain, I know. But I guess if you go with Occam's rule, at least in my version of it, I think it's a sounder version than what you have from the establishment. Okay, another fellow says, when CERN smash particles, why do they explode according to the rope model? Well, you don't have an explosion. What we have, let me show you what we have. You have two atoms, whatever they are, I don't care. They could be gold atoms, which is one of the atoms they use to smash against another. They accelerate two atoms. They crash. What is all this stuff that we see? Is there an explosion? Is there a ground zero, a nuclear bomb going on there? No, the answer is you're shaking two cobwebs. Take two cobwebs, from spiders, right? And you smash them against each other, and all the threads of the cobwebs are shaking. That's what they're detecting. Okay, they're detecting the vibrations. Remember, you have gazillions of ropes going in there, right? So you're smashing them, and it's all vibrating all over the place. Okay, so what you're measuring, what you're detecting, what your instrumentation is detecting are the vibrations of two cobwebs which have crashed against each other at great speeds. That's the way you got to conceptualize this, okay? At least that's the way I do. And they're 3D cobwebs, okay? They're not 2D. They're the typical cobweb is 2D. Now we're talking about 3D. The ropes are going in every direction. You're hitting them one against the other. All the threads are shaking, vibrating. Okay, folks. Well, if you have any other questions, leave them for next time. You can also put them in the description in the comments section. Okay? We'll see you next week. Bye-bye.